All right, let's dive right in. If you're a Swift developer, you've definitely hit this crossroads before. It's a choice that really shapes the foundation of your code. Class inheritance versus protocol inheritance. We're going to break down that crucial difference today.
I mean, this is the big one, right? Which one do you use and why? When you're mapping out a new feature, or even a whole app, you're going to face this decision. And let me tell you, getting it right from the get-go, well, that can save you a world of headaches later. So let's get into it.
And you got to understand, this is not just about style points. Nope. The path you pick here, it directly impacts everything. How easy your code is to maintain, how you can scale it up, and honestly, how easy it is for other people, or even you, 6 months from now, to understand. It's a huge architectural decision. Okay, so let's walk down path number 1. I want you to think about class inheritance like a family tree. Seriously, it's all about that direct lineage, a really clear hierarchy, and traits getting passed down from one generation to the next. So what does that really mean? Well, class inheritance is all about identity. You have a new class, what we call a subclass, and it inherits all its characteristics from one single parent, the superclass. This creates this super strong vertical link, something we call an is-a relationship. The cool thing here is you get to reuse and build on everything the parent class already gives you. You can even override some of that behavior, change it up. But, and this is the crucial part, in Swift, a class can only have one direct parent. That's it, just one. It's a single, straight line down. Let's look at a classic example. Imagine you've got a blueprint for a generic vehicle, okay? Now from that, we can create a car class that inherits from vehicle. And boom, you get this simple, totally logical statement. A car is a vehicle. It's a direct descendant inheriting all the core stuff from its parent. So, the big question is, when do you actually use this? Well, you'll want to reach for class inheritance when your objects have a really clear natural hierarchy. Think about things like animals or different kinds of shapes, or maybe user accounts with different permission levels. When you need to share not just what things do, but also what they are, their data, their state, that's when class inheritance is absolutely your go-to. All right, let's switch gears and check out path number 2. This is a whole different way of thinking. If classes are that family tree, I want you to think of protocols as a collection of skill sets. It's a total shift. It's not about who you are, it's about what you can do. Okay, so what is a protocol? The best way to think about it is like a contract. It lays out a blueprint of methods or properties, but here's the key. It doesn't actually provide the implementation. When a type, and this could be a class, a struct, whatever, conforms to a protocol, it's basically signing that contract. It's making a promise to fulfill those requirements. And this creates what we call a can-do relationship. It's all about sharing capabilities. And honestly, this is where things get really powerful and flexible, because unlike classes, a type can adopt multiple protocols. It can collect all these different skill sets. You're essentially getting a form of multiple inheritance, but it's focused only on behavior. You're not locked into that rigid class hierarchy at all. So for instance, we could define a protocol called drivable. Now this protocol, it doesn't care one bit if you're a car, a truck, or even some futuristic robot. It only cares about one thing. Can you drive? So a Tesla struct can just conform to it, and by doing so, it makes a simple promise. Yep, I can do the action of driving. And that right there is why protocols are such a game changer. They are perfect for defining a shared behavior that you want to apply across totally unrelated types. And what does that give you? Incredible flexibility. It keeps your code's components from being tangled up with each other, we call that loosely coupled, and that makes everything way more modular and way easier to test. Okay, we've walked down both paths. We've got the rigid family tree of classes on one side and the super flexible skill set of protocols on the other. So now, let's put it all together. Let's build a sort of guide map to help you choose the right one for the job.
So here we are, back at that central question. But now we're armed with a lot more knowledge, right? We have a much clearer picture of our options. So, how do we make the final call?
Let's just lay it all out, side by side. Class inheritance. That's your vertical is-a relationship. It's a rigid structure, and it's built to share both data and behavior. Protocol inheritance. That's all about the horizontal can-do relationship. It's flexible, and it's all about sharing capabilities. When you really boil it down, it's a choice between identity versus ability. So what does this all mean for the code you're writing? Like, right now. Let's talk about the modern Swift approach and how you should be thinking about this to build code that lasts.
Okay, if there's one thing you take away from this, let it be this. It is not about one being better than the other. It's about using the right tool for the right job. So here's the rule of thumb. If you can say something is a something else, and it just clicks, it makes perfect sense, then yeah, classes are a really strong option. But if you're thinking about capabilities that could be shared all over the place, across totally different things, protocols are almost always going to be the cleaner, more scalable choice.
And that kind of leaves us with one last big thought to chew on. You know, as modern code leans more and more towards being flexible and modular, you see the Swift community really favoring this protocol-oriented approach. So it makes you wonder, right? In the world of modern Swift, are protocols actually the new foundation for writing truly great code?